what we've heard in the conventional paradigm, the conventional story tells us that it's those random changes that has brought about all of this.
Sure. Back in the 1800s, when life was simple, when they didn't know what was happening inside the cell, they didn't know how complex genetics was, you could imagine all sorts of things. But now that we know what actually happens behind the scenes, the story gets a lot more complicated. You see, I like to say the genome is four-dimensional. Well, we have a one-dimensional string called DNA. And if you want to draw that out, you'd have to write all the letters of DNA out on all 3 billion of them. And then you have to draw lines or arrows from one part to another part, because this part turns this part off, this part interferes with this part enhances this. It's this huge two-dimensional interaction network. And that's where you have a two-dimensional genome.
I mean, let me stop you for a second, because this is really amazing to think about this, because I think in terms of a computer program that it's fairly static. I mean, the instructions are there, but you're talking about a program that is reprogramming itself. It's modifying its own instructions.
Oh, wait till I get to the fourth dimension.
Oh, okay.
Because of the third dimension first. The information in that first dimension, that linear string, has to be organized in such a way that when it falls into the third dimension, it still works.
Well, that's amazing.
Genes that are used together are next to each other in 3D space.
Are you saying that once this thing gets folded up, it's almost like we have a new set of instructions?
Yes, a new level of information.
Unbelievable.
That whoever programmed that first level needed to understand what was going to happen, have it work in the third level.
But you said there's another dimension even.
Oh yeah, the fourth dimension is time.
And how does that work?
The genome changes shape over time. Maybe you eat something that's bad for you, and your liver says, I can get rid of that toxin. Now, the chromosomes in the liver will change shape, expose that new protein gene, make copies of it, build a brand new protein that can kill off that toxin, and when it's not needed anymore, they'll change shape again and fold back.
Oh my goodness.
Dynamic programming. All 3 levels change in the 4th level, time.
Rob, that's so far beyond anything that we know, even in our most complex software systems, that it's almost beyond imagination to think that someone would look at that and say it all happened by chance.
Yes, and it only brings glory to God.
It does.
You can't build something like that up one thing at a time. You need it to function. In all this interlocking 4-dimensional complexity, it's not something you can do one letter at a time with natural selection.
It all has to be there.
Yeah, in the same way when we talked about the environment out here on the coral reef, if you don't have all these interlocking pieces to that puzzle, you don't have that ecology. The system will come crashing down if you just remove a couple of very important factors that are there. They have to be together or it doesn't happen.
So not only did we have this interdependency, this mutualism, so to speak, down at the genetic level, now we even make it more complex by saying there is that same mutualism at the higher level as well.
Yes. In fact, the entire world has a mutualism.
It's impossible to think that all of this could have happened just by a series of slow processes over billions of years.
That's exactly what I'm saying.